Greetings everyone, welcome to the Automation Kit channel. In today's short video, we will attempt a brief dive right into the action where we will use structured text programming and attempt to use the simulation function of Automation Studio. And today's video is for students or engineers who just want a quick dive or a quick look into how Automation Studio can be used without going through too much of the theory lessons or training. Yep. So before you start, if you don't have a copy of the Automation Studio, you can always download a copy and a request for the evaluation license, and then you can try to follow the video, and hopefully it helps you. Please take note that we are using Automation Studio 4.7. So even if you download 4.8 or 4.5, it should stay roughly the same. And as usual, please know that this is just an educational video and purely out of hobby. So if you have any questions or any official queries, it's always good to approach the local B&R office. Right, so let's get started. After you download Automation Studio, you have to license Automation Studio, and once you do that, you can open up the Automation Studio software, and once it opens up, you just need to start a new project. So to do that, just go to File and New Project. Up. The first thing we need to do is give your project a name. So let's just call it Quick Dive. Oops. Call it Quick Dive. And it's important to remember where you're going to save the project. So I put mine in the temporary folder in the root C drive. Yep. Okay, next step, press next. And here you are provided with a few options for today. And for today, we'll be just using the first option. So we will select the hardware by ourselves. For the name of the configuration, it's okay to leave it as it is. It's not important for now. And press next. Okay, so once again, you will see that there are a lot of options over here. So I will do a quick explanation. Normally, when you purchase B&R hardware, there are different models, and you just need to find your model and select the correct category, and then at the bottom you will see the model, and you just need to select that. So for today, let's just choose one of the PLC 1586. That's my favorite. Yep, you have two options over here. One is the coated, and one is the non-coated PLC module. I will leave that to you to find out what there is, but for the video, just choose CP1586. Okay, automation runtime type, we just use the AR embedded, and anyway, that's the only option available for now. So press finish. Okay, well done. So immediately you see the project has now been created, and you are presented with the hardware screen. Once again, I will just do a quick orientation. So here you can see a PLC. You can drag it around and put it at a place you like, but that's not important for now. You can close the hardware screen by pressing X. Okay, and if you want to bring up the hardware screen again, just go to Physical, and you can see the little button is called System Designer. Press this and it will appear once again. So just remember this part. Of course, to learn how to use Automation Studio, there will be a lot of you need to undergo proper training, and You can also check some tutorial videos online. I realize many of them are very good. They have very good content. So for a full experience, recommend you to have a look. But our purpose today is to really dive in quick and just do a bit of programming and just do a bit of simulation. So hopefully from here, by the end of the video, you should be able to play around by yourself and do some tests. And yeah. Okay, so I won't explain what the physical view is or what the configuration view is or what the logical view is, but just take note and keep in mind. Over here on the right side, okay. So on the right side, you have a toolbox. So the toolbox is where you select the objects and elements to add into your project. Right, so today our first order of business is to create a program, right? And as I mentioned earlier on in the video, we will be using structured text. So let's do that. Let's find the structured text and add that to our PLC. So all we need to do is remember, go to logical view first. Okay, oops, just put the window back. Okay, cool. It's a bit tricky, but you can, oops, I think there's something wrong with my mouse, but in case you ever run into the same trouble, once again, just go to Window over here, and you can choose Reset Windows Layout, and let's see what happens. Nice. So the good thing about Automation Studio is that sometimes if you mess up, you always have an option to go back to the original Windows layout. Okay, so program. When I want to add a program, it's always in the logical view. A good way to remind yourself is logic, it's program. So make sure you're in the logical view tree first. And over here on the right side, you see the toolbox. It changes. If I press configuration, the toolbox change again. If I press physical view, the toolbox change again. So the toolbox is dynamic. It basically adapts to which one you're using. If you're using physical view, it changes to show the items that you can add into the physical view tab. And if you choose configuration, it also shows the items that you can add into the configuration, and when you choose logical, it changes again, and here are the items that you can add into the logical tab. All right, structured text. Where can we find structured text? So you can see that there are a lot of program available. Where is, okay, cool. There are two types of structured text. I'll leave the first one to you to explore by yourself. But for today's demonstration, we will use ST program all-in-one. So just select that and drop it over here. Okay, nice. And we have no further need for our toolbox, so we will minimize that. Okay, cool. So in your project, you will now have a program whose name is called program. So let's change the name. I think this is something you have to do in your work or even in your project. So to change the name of the program, just right click and go to rename. Okay, just call it Quick Dive. Okay, cool. So now we have a program, a structured text program whose name is called Quick Dive. The next thing that I have to show you is how do you actually add this program into the PLC. So as you can see, the program is in the logical view tab, but it's not necessarily added to the PLC. You will see that in a short while. To access what is inside the PLC, just go to physical view you see X20 CP1586. Just click that and right click, go to configuration. Okay, a second tab will open, and wrong one. Apologies, that's not the right place to go. Okay, to see what program is running exactly on the PLC, what you need to do is to go to configuration view. Okay, and over here you will see CP1586. You just need to expand that, and you should see CPU.sw. Just click on that. Okay, so as you can see, right, when I added the program into the logical view tree, it's automatically created over here in the cyclic for task class. If you want to know what exactly cycle 1, 2, 3, 4, 5, 6, 7, 8, I will have that in a separate theory video. But for today, just keep it in mind, and we will just move on from here. So you can see that the program is already inside, and this is good enough for now. So we can close the software. And of course, as you might have noticed by now, we haven't even programmed anything yet, right? So to open up the programming console, just need to double click on your program quickly. Okay, nice. So what we have over here is just a blank program. You have the initialization, you have the cyclic, and you have the exit program. To keep things simple, over here at the program initialization, this is where you specify your initial values if you have or if you need them. And the program cyclic, this is the code that is running when the PLC is running, and it runs in cycles, hence it's called the cyclic program. We will explore that shortly. Okay, and then the last one is the exit program. Normally, if you need to remove the program or you have to give some instruction, you can put that in the exit program. And yeah, that's it for the moment. Okay, so to recap, what have we done at this point of time? We created our project. We have a hardware screen, and then we went into the logical view. Then we add a program, just drag and drop, and after that we went into the configuration view where we open up this CP1586, and we double click on the software, and we will just double confirm that okay, our program is now inside the PLC. Okay. So for now, the next step that we need to do, of course, is to activate the simulation, right? Because without the simulation, anything you code in the Automation Studio, you cannot observe the change, or you cannot really check your logic. So to start the simulation is a really very easy process. All that needs to be done is by clicking this little button, it says activate simulation. Okay, before I click that, I would like to bring your attention to the bottom right hand side of the screen. So you will see that it shows offline. Okay, so offline, and this button not being engaged, it means that your simulation is not active, and technically you have nothing to play with. All right, so let's quickly just activate the simulation, and what this does is that it will create a virtual PLC in your computer where you can transfer the code into this virtual PLC, and then you can test the code. And let's do it. Press activate simulation. Okay, and then you wait. Sometimes you get some warning, and just need to allow everything, and it should be okay. All right, so I think it didn't take too much time. Immediately on the bottom right hand side of the screen, you will see this little thing that pops up, this traffic light. It says ARSIM C4.72. To keep it simple, this is like the OS version of the PLC now. And that is not important for the moment, but most important is this run word. What it means that your PLC is running, your virtual PLC is running, and everything is good. If you see a red color word, and that is not good. But for the moment, we won't touch on that. Okay, so we have our virtual PLC running, and we have empty code over here. So the next thing I want to do is to transfer my code into the virtual PLC. Of course, my code won't do anything because there's nothing inside, but for the sake of it, let's do the transfer. So just like with a real PLC, the first thing you need to do is you go to project, and there's this little button that says build configuration. So what it does is that it basically compiles your code, and it also compiles the libraries and everything that you need to run your project, and it will transfer them into the PLC. So let's say you have two programs over here. One is Quick Dive, and for the fun of it, just say you have Quick Dive. Just change the name to Quick Dive 2. Okay, so if I were to do the project and build configuration right now, you notice that there is only the program called Quick Dive inside that is meant to be inside the PLC. So when I build the configuration, only the first program will really be transferred into the PLC. If you want the second program to be inside, you just have to drag and drop, and you have the two programs inside. So it's always a good practice before you transfer anything to check which programs are inside. Okay, cool. So I don't need Quick Dive 2. I just delete. Oops, just delete that. Okay. All right, cool, finish. All right, let's get down to building. Project build. You just need to wait. Okay, cool. And then you have this little window. It pop up. It tells you, okay, the build was done successfully. Blah blah blah. Just press transfer, and the transfer windows will come out. For now, we won't talk about the information over here. All you need to do is just press transfer, and you get a little warning. It says partition and format the selected target. Just press yes. Okay. Okay, nice. So the transfer to the PLC, the virtual PLC is now finished, and we basically have a virtual PLC running an empty program called Quick Dive. It's doing nothing, right? Next thing we want to do quickly is to go down to programming. It's we'll do a very simple program, and you can explore the rest by yourself. So just double click Quick Dive. Okay. Some tip for you is that you should go to Tools, Options, and what you need to do is to go to Smart Edit, and there is this option. Make sure it's being checked. It's called Automatically Declare New Variables. You will see why it helps in a short moment. Okay, let's see. let's do a very simple logic. Let's say if, okay, for now we will disregard the init program. Let's just go straight into the cyclic. Okay, do if and then and else, and you have an if. Okay, right. Oops. Take note, it should be in capital letters. Okay, then if button equals to true. So, and at this point of time, if you press the down arrow, your variable declaration will come out automatically. So this is a very helpful feature to use. If you're ever confused, what the hell is a Boolean, right? You just need to click on this type, this double click. You will see a little box that pops up. Just click the little box, and then you will have a bunch of description on the types of variables for you to use, and this is very helpful. So just press OK. Nice, I have just declared my first Boolean variable, and now I'll create a new variable called output equals to true. Okay, else. Okay, then you press the down button. It will ask you to declare again. So just press OK. It's a Boolean variable, and just copy this. Otherwise, output is false. Okay, so now we have the basic. The if and else condition is one of the basic building blocks of structured text. So you can explore the rest by yourself. Okay, so now we have the simple code over here, and we will save. It's always good to save a project. At this point of time, it's also interesting to note that your variable list, you might be wondering where is the variable list. So you can access the variable list by clicking this. This one, it says variables.bar. It's under the quick dive program. Just double click, and now you can see that these are the variables that we just created for the program. Okay, but we don't need that at the moment. Just close this. Okay, nice. So we have a very simple logic over here, and I'm sure you can guess the next step. And what we want to do is to build and transfer. It's the same thing. So let's just wait. Okay, I think that is quite fast. And you just press transfer. Okay, and that's okay. Press transfer. Okay, that was really fast. All right. At this point of time, yes, it's a virtual PLC. So sometimes when I transfer the code to my PLC, I would like to restart the PLC. But for now, we don't have to do this. But if you want, you can try to press the warm restart button. So this is another quick information for you. Okay, our program is now inside. And the next question you will have on your mind is, how do I observe the variable and how do I observe the logic? That is also a very simple thing. Simply go to your program under the logical view and right click. You will see the window pop out, and all you need to do is to look for the watch. Yep, so as the name suggests, its purpose is to watch. And we will just click on that, and you will see a new window pop up. Another quick tip, try not to have too much window around over here. And just manage your window and don't have too much windows, otherwise it will confuse yourself. Yeah, so we have the program over here, we have the hardware page, this hardware designer over here, and then we have the watch window over here. So for the watch window, obviously what we want to watch are the variables, right? So just right click and choose insert variable, and you have the button and the output. So just select both of them and press add, and you have this. They are now added, and let's see them in action, right? So our button is false, and according to our logic, it says if button is true, output is true, otherwise it's false. Okay, so false is false, and if I put to true, it should be true. Yep. So congratulations if you if you manage to follow this step, and then you have just completed your first program, right? Of course, you can explore further on from here, and let's try to push it a bit more. And so we will go into hardware page. As we know, it's not fun to just have this simple program running inside your PLC, right? So we need some sort of digital input or digital output module, and so yeah, we will go into it, and I'll just show you guys how to add the hardware. Okay, right. What you need to do when you want to add any type of physical hardware, is always important to go to the physical view, because that is how you add the hardware. So let's see. Okay, and you have the recent tab, favorites tab, and catalog tab. So I will just type in the word DI, stands for digital input, and you just need to scroll downwards. You just find any digital input modules. Let's see, and you have okay, let's try to use this. It says 2 digital inputs, 24 VDC source. Okay, fine. So it looks like this. So you have the picture at the bottom. We'll just drag and put it over here. So you see that it automatically attaches over here. Okay, and nice. So well done. You just you have added a digital input module, and we don't need the toolbox catalog anymore. Okay, so now let's take a look at the physical view. As a recap, from the start until now, we have only been using logical view. Logical view is where you add the program, as simple as that. In configuration view, you can do a whole bunch of other things, but the reason why we go into configuration view just now is just we want to have a look at which program is actually running on the PLC. So we have this one. Okay, next one is physical view. So what we have done is we have added the X20DI, which stands for digital input 2372, into our onto our PLC. So I see it's attached over here. In real life, it attaches there as well, so it's not a big issue. What we want to do, right, is we want to use the digital input to trigger our button. So instead of using the watch window to trigger, can you imagine that you have a button from outside, right? So it's digital input button from outside that is trying to send you a digital signal. So to do that, it's very easy as well. Just go to physical view, right click, and go into I/O mapping. This stands for input and output mapping. So just need to click on that. Okay, and over here you only have 2 options. This is only specific to this particular module because I chose the one with 2 digital input. Let us use digital input 1. Just double click, and once again you see the little box with the 3 dots. Okay, so just click on that, and you'll be presented with a bunch of with whatever program you're running on your PLC, or it's available on your PLC. So currently I only have the quick dive program. You just need to expand that, and you realize that you only have an option of 2 Boolean variables. So let's just use the button. I think that should be it. Okay, so once you have this, you notice that a bunch of stuff gets filled up. You can ignore that for now, but what you need to do is to save your project. You might see this little star over here. So this little star means that the changes are not being saved. So you just need to save. Okay, cool, nice. So you have mapped your first variable to the digital input module. So that is done. You can close this window. What we want to do next is we want to build and we want to transfer. And just wait. Okay, cool. Then just press transfer. Okay. Okay, nice. So now that's done. The next thing that comes to our mind is, yes, this is a simulation, right? So there's no way I can connect a button to my laptop or connect a button to my PC at the moment. So there has to be some way to simulate the digital input that is being pressed. And let's do it now. It's the same thing, just right click on, press the IO mapping. Okay, so on the other hand, you should have your quick dive watch window over here so you can observe the change. So let us simulate the digital input being triggered. Okay, to do that, just press this button. It's called the monitor, and you will enter into the monitor mode. Okay, from here on, you can start to play with the digital input 1. So to forcefully activate the digital input 1, just select this, just tick this checkbox. Okay, and then current force value is false, so I will force it to be true. You can type true or you can just type 1, it doesn't matter. So just do that, and then let's see the variable change, and there you go. So I put it to true, and now the button is true. So, and as a result, the logic is working and you get the output. So after that, I put it to 0, which is false. Go back to check again. And okay, perfect. So this is how you map a variable. This is also very important. And it's an important aspect of Automation Studio, so it's good to know. Okay, so we are not using monitor mode anymore. We can just turn it off. Okay, we can close this window as well. Just keep the quick dive watch window on. Okay, so back to the hardware designer page. Normally we have a digital input. We also have a digital output, right? So let's repeat the process. Let's add a digital output module. We have to find it. Recap. Logical view is for program. Configuration view is for a lot of things you will see in the future. Physical view, this is to do with the hardware. So always go into the physical view tab and your hardware catalog will change accordingly. And you have digital input. Now I change to DO, which is digital output. So let's find the digital output. Okay, just scroll down, digital output. Okay, so earlier on we have like 2 output, right? Let's use a 4 output. So it's the same process as before, just drag and drop. Okay, finish. And then you can minimize your hardware catalog. So if you like to have the catalog pop up automatically, you can just use this button, and then it goes in and comes out. So you have more space. So I believe at this point of time, you realize that adding the hardware in Automation Studio is really easy. You just find the hardware you want, just drag and drop and finish. And let's not forget, now we have the DO, which is the digital output. The name is 4321. Let's map the digital output. So right click, go into IO mapping as well. Here we have a selection of 4 digital outputs. So let's just map it to one of the digital output. Process is same. Just double click and click this little box and go into our program, the output Boolean variable. So it's now being mapped and save. and close the IO mapping. And I don't think we need to observe this anymore because we can just check from the IO mapping. So let's close the quick dive. Do you want to save the configuration? Yes, just put yes to anything for now. And project build. Okay, perfect. Nice. So just transfer. Okay, so that's it, done. Finish. All right, so let's bring up the IO mapping for the digital input. Let's bring up the IO mapping for the digital output so we can observe what's going on. We can close the program page. Don't need that for the moment. For the hardware page, let's close it as well. We won't be adding any hardware for the moment. And then you might notice that it's very difficult to switch between the page, right? So let's do something cool. All you need to do is to take one of the page, the digital output, click on it and drag it downwards and release the mouse, and there you go. You have two separate pages, which is a much better way to monitor the change. And then don't forget to go into the monitor mode. All right, so let's see. I'm going to force my digital input because we want to simulate a button signal being received. So I put it to true, and then you can see the output of the module becomes true as well. Yep. So in reality, when you work with a lot of B&R hardware, you need to put them into the hardware tree, and then you just need to map the variables. Same goes for analog values. Take note, we are playing with digital values for the moment. We are not doing any analog values. So yeah, that's that. And now we finish with a very simple program. Okay. Let's see what else. Okay, another thing maybe to help you would be, let's look at some simple arithmetic. So I'll do the program first, and then let's observe the result. Okay. I'll have a simple variable. I call it counter. Okay, I mean, to keep it even more simple, I call it number. And then equals to number plus 1. So every cycle, the value of number increases by 1. Okay, so press the down button. It will trigger the variable declaration by itself, but we don't want to use the Boolean variable here, right? So we should be using something like, let's just use the int, right? I think that's, but of course you can use int if you want. The range, the only difference is the range, but and also the memory size. So let's just use int. Okay, cool. All right. Now our variable is being declared, and all that is left is to, you know what? Maybe I think it's better I change the number to dint, double integer. I think because integer is a bit too small. So now we have a problem, right? I want to change. I declared a variable, but how the heck do I change the variable then? Too late, right? But not really. All you need to do is to go to the variable. Okay, over here, just find the variable. It says number int. Okay, change dint, and you're done. Save, always save. Close this window. Okay, so now it's a dint. How do I know it's a dint? Just hover your mouse over. It shows you dint. Okay, and what we want to do is to declare the initial value for the dint. So as I mentioned earlier on, you use the initial cycle to initialize a value when the PLC starts to run. So I want my initial value of a number to start with, let's say 1000. Yep, so this will be the initial value. Okay, and save project, build configuration, and wait for the transfer window to pop up. Okay, transfer window is up, just press transfer, transfer. Okay, finish, done. Now, let's go into, you might have guessed it, to observe the variable, you always go into the watch window. Okay, we are not interested in button and output anymore, so we delete that. We want the number. Okay, so you can see the numbers are jumping pretty fast. And if you want to know how fast it's jumping, the rate at which the number is jumping, let us go back to the configuration view where we earlier on look at this software configuration. Okay, so now it starts to make some sense. Okay, you have your quick dive program in cyclic 4, which runs at the rate of 100 milliseconds. So every 100 milliseconds, the program executes once. And as you can see, 100 milliseconds is about 0.1 second. So in 1 second, it executes 10 times. So the number over here should also jump 10 times per second. So logically speaking, it also means that if I were to move this quick dive program down onto cyclic 7, my number should then jump once every second. Yeah, but now we just need to save. Okay, we will try that. We will save our project. You will see that it doesn't change immediately, right? Of course, because we need to build and transfer, and then we will observe the change. Right. So transfer. Yep. So this is also an important thing to take note when you're using Automation Studio, because this allows you an immense amount of flexibility in how you want to design your program. Say, for example, you have a sensor, right, that's on the assembly line in school or on the assembly line in the factory, and you don't need your sensor to run at such a high frequency. So that is to say, you don't need to monitor the output of the sensor so frequently. You can, you can just put it like at, you can just put a program at 500 milliseconds or so. And let's say you have a program that needs to be executed with a high frequency. You can put it to the cyclic task class 1. And for the further explanation, I recommend you to check out some of the other tutorial videos that provides a very good in-depth explanation of the cyclic task class. So we won't talk about this today, but just take note. So now it's in task class 7, which runs at 1 second, at a rate of 1 second. So let's check the output. So as you can see, now it's running like a clock, and the value changes every 1 second. So this should provide you some brief introduction to how to use this cyclic task class. And I think, okay, so it asks you if you want to save, just save, it's nothing big. Okay, what else? Yes, the last part. So the most important thing about the PLC is always the IP address of the PLC. Otherwise, you won't get to talk to the PLC. So to set, just like how you need to set the IP address of a laptop, right? You also need to set the IP address of your PLC. I will just provide a very brief idea on how to do that. Normally, you communicate with your PLC, the B&R PLC, via the Ethernet interface. So we need to go to the Ethernet interface. Under the physical view, right-click, go to configuration. Okay, it's don't be overwhelmed. Just need to look for this part that says get IP address from DHCP server. You don't need that. Change it to enter IP address manually. So subnet 255.255.255.255, right? So if you want to know why, you can go online and read a bit about the IP address, but if not, you just enter the IP address for the PLC 192.168.1, let's say 99. So this will become the IP address of the PLC. Yeah, you have to do that and just press save. But if you're using simulation, right? If you're playing with just a simulation, there's no need to really put the IP address for the PLC. It has a default IP address. You don't need to care. But if you're running on the actual hardware, you need to specify the IP address of the PLC. Otherwise, you won't be able to connect to the PLC. All right. So I think we have come to the end of the video. I will just summarize a bit. What we have done is at the start, we created the project. I'll show you how to do that. I also show you how to select the hardware that you need. And I also show you how to create your first program. And as you can see, it's not that difficult. It is a very simple program to save time, but I think with this knowledge in mind, I think you are in a very good position to expand by yourself and create a much more complicated structured text program and try it out yourself. And we also learn how to add the hardware, the I/O slice onto the PLC, and most importantly, we also learn how to map our process variables, as we call them, to the I/O slice, so that any change in the program is being reflected in the I/O slice, and the I/O slice can give the correct output to the other devices that are taking the information from the PLC. And yes, so this is just a very quick dive and to help you to get started with playing around in Automation Studio. In reality, the training, the official training, I think it's a few days. So there's much more than meets the eye for the software, and there are a lot of things that you can pick up along the way. But I'm confident that with what we covered in the lesson today, you should be able to play around and design your own logic. And just a last message. The help, I know this is, how should I put it? The help is really very good, I have to say. It's like it's almost like a textbook by itself. So if you're ever lost, I would really recommend you to check out the help. Okay, just click the help explorer over here. So let's say we are doing structured text, right? So maybe we can find. Okay, so so you can see the code. For example, you want to use some function blocks or some functions. You can always search. They have examples in structured text and also examples in NCC. So it's like a textbook by itself. And over here you can also check out a lot of things. It's basically huge inside. So if you ever run into trouble, I would really recommend you to check out the help. It's really very useful. And I think that will be the end of the video for today. So if this video is helpful to you, please leave a like. That would really be a big encouragement. And I wish you all the best in your effort to learn Automation Studio. And yeah, see you soon.